Okay, consider 4 carboxylic acid, which is the relative order of decreasing pKa. So actually means what they try to say is from high pKa, right, high pKa to low pKa, alright. So which means this is high means a weak acid, weak acid to stronger acid, yeah. All right, so which is the strongest acid? Okay, the strongest acid is probably the one that can form a stable conjugate base, right? So actually if you look at it carefully, it's this one that can form a stable conjugate base. It's actually number 4, right? Why is that? So when we look at pKa, we're actually looking at the Ka of these acid. We are looking at all these. So I'm going to draw out very quickly. All right, so let's look at the conjugate base of this carboxylic acid. So when you form the conjugate base over here, all right, let me just draw nicely. Okay, when you form the conjugate base over here, this is a quite stable conjugate base because there is actually hydrogen bond. Can you see that? There's actually hydrogen bond. So this hydrogen bond stabilizes this CO minus, right? So which means the strongest acid must be number 4. Okay, I just could put 4 here first. Okay, let's look at the next stronger acid. Okay, you need to know that electron donating group will actually make it a weaker acid, and weaker acid if it's an electron donating group. Okay, so over here there are 2 electron donating group, but which one is a stronger electron donating group? Is actually OH. So the lone pair of O can delocalize in the ring. Okay, but CH3 is just electron donating. It's just mildly electron donating. So let me draw it out very quickly. So let's look at this compound. Let's look at number 3. All right. So this negative charge, actually this negative charge is supposed to be able to delocalize into the benzene ring. Okay. All right. It can delocalize in the benzene ring. So actually this is how it works. Okay, the negative charge can delocalize to this carbon and actually into this oxygen. At the same time, it can delocalize into the benzene ring. So if OH is electron donating, all right, it increases the electron density in the benzene ring, all right. So the negative charge, less of the negative charge can delocalize into the benzene ring, less of it because of the high electron density in the benzene ring. So less can delocalize. So this negative charge is dispersed to a lesser extent. Okay, so if it's dispersed to a lesser extent, all right, it means it's actually going to be the acid is going to be a weaker acid. Okay, it's going to be a weaker acid. So the weakest acid here is actually number 3. Okay, then the next weaker acid is CH3. CH3 is also electron donating, but it's only mildly electron donating, unlike phenol. All right, so it's mildly electron donating. It also make it a weak acid, but it's not as weak as with OH group attached to the benzene ring. So the next weaker acid is number 2. All right, and then 1, because 1 has the absence of any electron donating group. All right, so it is actually stronger than 2 and 3. All right, stronger than 2 and 3. So the answer for this question is actually 1. All right.